Hello everyone, welcome to this Terraform full hands-on course for DevOps engineers. If you are learning DevOps or cloud engineering, Terraform is one of the most valuable skills you can pick up right now. Companies use it to manage thousands of servers, databases, Kubernetes clusters, all with code. Here's the reality. One wrong Terraform config can cost a company thousands of dollars, but when used correctly, Terraform makes infrastructure management simple, safe, and repeatable. This course is going to be 90% hands on. We will write code together and deploy real resources, break things on purpose, and fix them step by step. If you are doing this for the first time, don't just watch, open your terminal and follow along with me. That's the best way to learn. Also, quick heads up, I recently uploaded a full 2 hours DevOps course covering Linux, Jenkins, CI/CD, real world labs. If you haven't seen that yet, check it out after this video. I'll link it in the description and in the cards above. It's the perfect companion to this Terraform course. And of course, before we dive in, make sure you subscribe. I post new DevOps labs and real world disaster simulation every single week, and subscribing ensures you don't miss them. Alright, let's get started with Terraform. Before we jump into coding, let's understand the 6 key building blocks of Terraform. Number 1, IaC. It's nothing but infrastructure as code. Instead of manually clicking in the portal, for example, AWS portal or Azure portal, you write everything as code. This makes your infrastructure versioned, reviewable, reproducible. Okay? Now let's talk about the number 2. That is providers. Terraform itself doesn't know AWS, Azure, Docker. Providers are plugins that let Terraform talk to all these platforms. Okay? Now let's talk about resources. Resources are nothing but EC2 instance, Docker container, Kubernetes cluster. These all are resources. Okay? Number 4, state file. Terraform keeps a state file. It's memory. It records what resources exist, how they map to your code. This is how Terraform detects drift, by checking the state file. Number 5, variables. Instead of hard coding values, you pass inputs. Variables are common across multiple programming languages. For example, in Terraform, we use for image names, ports, region. This makes configurations reusable. Last but not least, outputs. Terraform can return values after creating resources. For example, container IDs, IP address. These can be used in scripts or CI/CD pipelines. If you are clear on these 6 concepts, you already have the foundation to use Terraform like a pro. Let's jump into the terminal and work hands-on. So I'm using my virtual machine. The first step is like we are going to download HashiCorp security key using this command and save it so apt can verify Terraform packages are real and untampered. Press enter. I'm going to give the password. Press enter. This is done. We tell the apt where to find the HashiCorp packages for our CPU and our Ubuntu version, and we log this repo to the key we just saved. Press enter. This is done. Let's quickly look at the repository list. That is clear, and also we can see it is like signed by this particular key. Now I'm going to clear the screen. Now we are going to refresh apt so it sees the new repository. Then also install Terraform. Press enter. So Terraform got installed successfully. I'm going to clear the screen. Now let's try to run Terraform space hyphen hyphen version to check if Terraform got installed. Yes, I can see Terraform v1 13.1. That looks fine. Now we are going to download Terraform on Windows. That was, let's say, Ubuntu version. I would like to use Windows for this demo, so I'm trying to install here as well. It will be easy for me to use Visual Studio Code and other stuff. So I have this zip file downloaded. I'm going to extract this, extract all, and we are going to select a destination. For that, I'm going to use program files. Press extract, continue, continue. So we have Terraform in this location. I'm going to copy that location and open system environment variables real quick, and then click on environment variables, and then click on environment variables. Here we are going to select path, click on edit and add a new path. Click OK, OK, OK. Done. Now real quick open PowerShell. Here we are going to say Terraform space hyphen hyphen version. Press enter. Now we can see the same Terraform version on Windows as well. Terraform space hyphen hyphen version. Press enter. So the same version we have on Windows and Ubuntu. As we are doing everything locally, we need to install Docker. For that, I am going to say sudo apt install docker.io. Press enter. It will install Docker. We need this to do it locally, and also we are using Terraform to create some containers locally. I'm going to clear the screen. Docker space hyphen hyphen version. Press enter. We have Docker installed successfully. I'm going to clear the screen. Now let's go back. Okay, now let's jump into the Visual Studio Code real quick. I'm going to use Visual Studio Code for writing the code, also editing, because I'm very much comfortable with this particular tool. Let's create a folder first. For this, I'm going to say 01 basic container. Okay. In this folder, we are going to write Terraform file, main.terraform. Okay. Very simple. First, I'm going to start with Terraform followed by required providers. So I'm using help here so that it will be faster for me to write. Okay, here I'm going to say Docker is equal to, and I'm going to give the source here. Source would be crew worker /Docker. So I'm going to copy paste this source location followed by the version. Followed by version would be 3.0. I'm going to save this. So here we are saying Terraform to download Docker plugin from this particular source. Version would be 3.0. Okay. Resource would be Docker image followed by name. You can name it as you like, but I am giving nginx here. The actual image name with the version, that would be nginx 1.25.3. That's it under the resource. Followed by we are going to create another resource. This time that would be Docker container. Okay, we are telling Terraform to use nginx image and create Docker container. Here under resource, we are going to say image is equal to Docker image. I'm going to copy from here. There's like a typo, I guess. Image. I'm going to copy this and paste it here. Okay, Docker image dot nginx dot name. So I'm directly referencing this particular resource here. Okay. Then once again, name is equal to nginx basic followed by ports. I'm going to open braces here. Internal is equal to 80 followed by external is equal to 80. So everything is like hard coded here. Now let's navigate to this particular directory, and in this directory we are going to say Terraform init. It will try to initialize the backend, also initialize the provider plugins. If you see, it is trying to find the Docker provider plugin and trying to install. Okay, it installed successfully. Now I'm going to clear the screen and then say Terraform plan to check what Terraform is trying to install. So if we look at the error message here, planning failed. It says provider requires explicit configuration. Add a provider block to the root module. Add a provider block to the root module. Error pinging Docker service. Docker error pinging Docker server. Please make sure this is like available. Okay. I know what's the problem here. I need to open my Docker desktop because I'm doing it on Windows. I need to open this. So once our desktop is, let's say, running, it should work. Yes, I did start my Docker desktop. So if you can see, I'm going to move this here. Now we have our Docker desktop. Once again, let's say Terraform plan. If you see, now it is successful. So look at this message carefully. Resource Docker container nginx. This is what we provided here. Okay, Docker container. And if you scroll down, we provided Docker image.nginx. Okay, this particular image will be created. Plan 2 to add, 0 to change, 0 to destroy. You can check in detail. We have the ports we described in our code, and also there are, like, let's say, some other values as well, which are, let's say, not required, mandatory. For this video, I'm going to keep it very simple so that it will be easy for you guys to understand. Also, here you can see a note. You didn't use the -out option to save this plan. So Terraform can't guarantee to take exactly these actions if you run Terraform apply. That's fine. Now I'm going to clear the screen and say Terraform apply. Press enter. So it is again asking if you want to deploy, yes to approve. Press enter. Now Terraform will do its job. I don't need to do anything. Apply complete, resources, 2 added, 0 change, 0 destroyed. Okay. Now let me clear the screen. Docker ps-a. If you see nginx 1.25.3, this is the exact version we just deployed using Terraform. That's how you will try to deploy infrastructure using Terraform locally. Now, let me clear the screen. I will try to destroy that. It's very simple. Once again, Terraform destroy, press enter. It will ask, plan 0 to add, 0 to change, 2 to destroy. Say yes, press enter. Now if we say docker ps once again, our our container is gone. Let me clear the screen. Docker ps-a. If you see, I don't see that nginx container at all. And that's your first Terraform deployment. No Docker CLI, just Terraform code. Next, we'll add variables and outputs, and then we'll test Terraform secret weapon drift detection. Now let's create another folder. That would be variables outputs folder. In this folder, once again, I'm going to create main.terraform file. Here, again, same configuration, Terraform followed by required providers, Docker is equal to open braces, and the source would be crew worker Docker, followed by the same version. I'm going to copy paste from here so that it will be faster. Copy this version, come back to main.terraform and paste it here. We are going to create the resource. Here the resource would be Docker image. In the name, I'm going to say web so that it will be clear to understand. Also, in the name, I am going to say variable.image. Okay, I'm going to save this. Previously, we called it as, we hard coded this value here, nginx 1.25.3. In here, I'm going to say variable.image. Next, resource, Docker container, web, followed by image. Image would be Docker image.web.name. Press enter. Then name once again. Here I'm going to say nginx underscore var. Ports, same exactly. I'm writing the same steps once again. Ports would be internal is equal to 80, followed by external would be variable.external port. Previously, if you compare, we wrote external as 8080. Here we are providing a variable. Now I'm going to create a file that would be variables.terraform. So in this variables.terraform, I am going to write variable image followed by description. A small description saying Docker image to run. Space, type would be string followed by default. Default here is nginx. We can provide a version here. So for example, if nothing is provided, I am going to say version 1.25.3. Then second variable, we gave two variables in here. If you remember, variable.image followed by variable.external port. So here I'm going to say external port. Description once again, In the description, host port to expose. Okay. And the type would be once again number. Default is 8081. Save. Variables file is like done. Now I'm going to say outputs.terraform. So in the outputs.terraform, output container ID. In the description, we will give it as ID of the created container, followed by once again value here. Value would be docker container web id. So if you see docker container web id, we are trying to output this particular value, followed by I'm going to say another output, that would be host port. So we will see this as output values on our terminal screen. You will see that in a moment. Docker container web ports 0 dot external. In the previous file, we were hard coding the entire code. In this folder, we are going to pass variables using this particular file. Let's navigate to 02 variables folder. In this folder, once again, we are going to say Terraform initialize. So exact same steps we are following once again. And in this case, now Terraform plan. Press enter. I need to save the file. Looks like I forgot to save the file. Now let's say Terraform plan, press enter. So if you look at the output once again, it's the same output. Docker container web will be created, followed by docker underscore image web will be created. Here we can see the values which we defined. nginx 1.25.3. So in the main file, if you see, we have variable.image. In the variables, you can see this 1.25.3. So this is how we need to pass variables. Always make sure you're not hard coding the values. Variables are the best way to create resources in Terraform. They are easily repeatable and reproducible. Before jumping in, I'm going to do docker ps, press enter. I don't see any containers name. I don't see any container names with nginx var, and we are going to pass a different port here. So in general, in our variables we had external port as 8081, but I want to pass 9090. Press enter. So if you see, the host port is pointing to 9090. Say yes. So it will try to create docker image and container as well, but on port 9090. So if you look at the output here, apply completed successfully, 2 resources added, 0 change, 0 destroyed. And we can see the output. I can see the container ID output and also host port as 9090. This is how outputs are useful. I can see the container ID and host port, and directly I can see if the container is, let's say, running or not. I'm going to clear the screen now. Let's try to run docker ps filter name nginx, press enter. Our nginx var container is ready on port 9090. This is how you try to use variables, output files, and deploy your resources using Terraform. If you are following along and learning something new, hit subscribe right now. I upload new DevOps labs every week, and subscribing ensures you don't miss the next one. Alright, let's talk about one of the most important but often overlooked parts of Terraform, the state file. Whenever you run Terraform apply, Terraform doesn't just magically remember what resources you created. Instead, it keeps track of everything inside a file called terraform.tf-state. I'm not sure how many of you watched this file getting created from the beginning. I wanted to talk it I wanted to talk about it later. So here we are discussing about terraform.tf-state. If you look at clearly, you can see the container ID which I was showing and also the host port 9090. Think of the state file like Terraform's memory. It records what exists in your infrastructure, the IDs of resources, and all the attributes needed to know the current state of your system. Without this file, Terraform would have no idea whether a VM already exists or need to be created. First, Terraform state file allows Terraform to compare what's in your code versus what's already deployed. That's how it knows whether to create, update, or destroy resources. Second, if you lose or corrupt this file, Terraform might try to recreate everything, which could be very risky in production environment. Third, in real teams, the state file needs to be shared, so we usually store it remotely. For example, in S3 bucket or Azure storage account instead of just keeping it locally. So for this video, I'm keeping it locally, but in production environment, this file should not sit in the local directory. It should always reside in cloud environment or a storage account. So in short, the Terraform state file is not just a random JSON file, it's the single source of truth for your infrastructure. Protect it, back it up, and make sure it's in a safe place when working in a team. Now let's talk about the most interesting and the very important topic in Terraform, Terraform Drift. In this folder, I'm going to create main.terraform, and in this file, I'm going to paste this same exact stuff which we were doing previously. Required providers would be Docker. Source is like the same again, version is like the same. Here the resource is like Docker image. I just updated to Alpine image, followed by Docker container. Once again, the name would be nginx underscore drift. So here, let me update it to name. Now, once again, we are going to say Terraform initialize. Okay, let me come out of this folder and go to 03 folder, and clear the screen. Terraform initialize once again. So after the initialization, we are going to say Terraform apply. Clear the screen. Terraform apply, press enter. Say yes. It is trying to add same exactly two resources, 0 to change, 0 to destroy. I am going to, okay, this is done. I'm going to clear the screen. If I try to run Terraform apply once again, what do you think it should do? Will it create new resources or will it say 0 changes, 0 destroyed? Exactly, because it remembers that we have the resources in this particular file. Okay, it is trying to check what's in the state file and also trying to compare with Docker. Looks like we have the resources deployed already. There's no need to deploy it once again. Now I'm going to say Docker PS. I can see nginx Alpine. Now let me try to stop this manually. Docker space stop container. Press enter. If we look at Docker PS, now this container is gone. I stop this container manually. Okay, let me clear the screen. Now if I say Terraform apply, do you think will Terraform try to create this container or not? Let's check out. Press enter. If you see, Terraform tried to compare, okay, with Docker, and it sees there is a drift. That means it is unable to see the container, so it is trying to recreate. In general, previously when we ran Terraform, we saw two resources being added. But right now I can see only one because I only stopped the container. I did not remove the image. Okay, I'm going to say yes. Resources 1 added, 0 destroyed. Let me clear the screen and let's do docker ps once again. So if you see, we have the container back, and let me do it once again. Terraform apply. Now I don't see that. So this is called Terraform drift. This is, let's say, very dangerous situation. We have to be very careful in production environment. Always we should have proper guardrails in place so that you are not touching anything manually. If you are doing anything infrastructure as code, you have to be very strict so that you will avoid these kind of issues. Here I'm doing it locally, it's very simple, not an issue, but in production environments, this is like, this is, let's say, very dangerous, because we will have lot of dependencies, lot of other stuff tied to each resource. So deleting anything manually will break the whole system. We have now made configs reusable and seen how Terraform fixes drift. One of the important concepts in Terraform infrastructure as code, modules. Inside modules, I am going to create another folder called modules, and in modules I will say nginx container. This is like one of the folder, and in this folder I will say main.terraform followed by variables.terraform. I'm going to move this file in here. So in this main.terraform file, we are going to copy this from here, from variables output folder, and I am going to paste it here. It's the same name. It is exactly same stuff which we are doing here. Once again, Terraform required providers would be, let's say, Docker. Source would be this location, version, followed by the resource would be Docker image, and then Docker container. Variables. So for variables.terraform, I'm going to copy this file from here and paste it here. That's it. And if you come back to this main.terraform, here I'm going to update the name with a variable.name. Followed by here I'm going to add that variable. Name description would be container name. Type would be string here. Default nginx container web. Save this file, and now in the root folder of this location I'm going to add main.terraform. In the main.terraform I'm going to say module, and name would be nginx, followed by the source would be /module/nginx container, and then name. So name here I would say nginx mod, that is like a module. Then port, here it's like external port, I'm going to say 8083. Save this file. We are creating a module here. I'm using the same exact files, resource docker image, resource docker container, ports and the variable file, followed by on the root location of this particular folder, I have main.terraform. In this main.terraform, I'm just saying module, nginx, source, name, external port. That's it. Now I'm going to say Terraform init. So before doing Terraform init, I'm going to run Terraform fmt. That's Terraform format. That will try to format our structure of the code. Now let me run Terraform plan. So it says module is not installed. So I need to install this. How can we do that? It is also showing Terraform init. Terraform init. Press enter. So it will try to install that particular module for us, and then we should be able to run Terraform plan. So if you see plan 2 to add, 0 to change. If you see the image name version 1.25.3 and the same exact version which we have here. It is using modules, and main.terraform has only 4 lines of code. If you write modules once, that's it. It can be reusable multiple times. Let's say if you create a virtual machine module, you will just come here and you will just say, I want to spin up 100 virtual machines. That's it. And you will say Terraform plan and apply. Your 100 virtual machines will be ready. You don't need to write for each and every virtual machine the Terraform code. Let's say virtual machine 1, 2. That would be, let's say, very difficult. That's why we have modules in place. Now let's run Terraform apply. Press enter. If you see plan to add 2, say yes. Resources got created successfully. Now I will say clear the screen and docker ps once again. You see docker nginx container is like running. I would say Terraform destroy. Say yes. We have successfully created resources using modules. We did create basic container. We looked into variable outputs. We also looked into drift demo, modules. Now comes the very interesting topic of this particular course. We are going to deploy a virtual machine in the Azure cloud. For that, I will create a new folder. The folder name would be VM Azure deployment. I will try to move this folder out. So we are going to deploy Azure virtual machine in Azure cloud. There are some prerequisites for doing that. I'm going to open real quick my repository browser. So if you look at here, we need to have Terraform installed and also Azure CLI, an active Azure subscription. You can do it for free. The first step is like we need to log into Azure CLI. So let me do that real quick. From the terminal, I'm going to run AZ. From the terminal, I'm going to run AZ login. Press enter. Followed by, I will try to provide the username and password. We did sign in successfully using AZ login. We need to provide the username and password here. After that, I'm going to real quick create a main.terraform file, followed by variables.terraform file and output.terraform file. Outputs.tf. So let's start with the main.terraform file. When we were deploying locally, we were using Terraform required providers as Docker, source, and version. Whereas if we go with the Azure cloud, here I am going to say provider, Azure RM, Features. This is a required block for Azure RM provider. It doesn't need any arguments, but it must be declared. It enables the provider's internal feature toggles. Normally, we are going to create resource group. For example, resource Azure RM resource group. Example, I am trying to follow the documentation. I'm going to share it with you as well. So this is the official documentation from Terraform, Azure RM Linux virtual machine. So if you scroll down here, I can see example usage. So you can go through this. This is free. I will try to link it in the description as well. You can look into that and go through in detail if you are interested. But for this tutorial, I want to keep it very simple. So I'm going to explain what I have prepared for this video. So in the previous version, we used to create resource, Docker image, name. Same exactly, we are going to create Azure RM resource group. This is where we try to create resources inside this particular resource group. Name, location. But I'm not going to use this. I'm going to use the existing resource group. I don't want to create a new resource group because I'm not allowed to create. I have some, let's say, limitations there. Let me write a comment here. Use an existing resource group. Okay. Here I'm going to use data block. In the data block, I'm going to write Azure RM resource group. And here I will write RG, let's say the short form. Name would be my existing resource group that I am going to update later. Followed by, we are going to create a virtual network. Once again, resource. For each and every resource, we have to start with resource Azure RM virtual network. Name would be VNet here, and we are going to provide a name demo DevOps VNet, followed by the resource group name. Once again, that would be a data block that we are going to pass in. Press enter. Location would be variable dot location. We are going to pass the location in the variable file. Then address space. So address space, I am going to write 10.0.0.0/16. Then comes the subnet. Azure RM subnet. Name would be subnet. Once again, the subnet name here, demo DevOps subnet, followed by the resource group name. It's the same exact stuff we are going to write. I'm going to copy paste this so that it'll be faster. Copy and paste it here. Virtual network name. So in this case, we need to write this here. So I'm going to copy this. Azure RM virtual network dot vnet dot name. So we are, after creating these stuff, this will get created. Okay. Terraform will take care of the dependencies. We don't need to worry about anything. We just need to focus on writing the correct code. There are some cases dependencies are, let's say, created correctly. But in this scenario, virtual machine, this is like a very simple one. So we don't need to worry about anything. I'm going to add address prefix here, 10.0.2.0/24. This resource is done. Now, next, public IP. So if we have to connect from our virtual machine, I mean my local machine, we need a public IP to the virtual machine. So without public IP, I cannot connect. So I'm going to create a public IP, Azure RM public IP. Name would be once again public IP here, followed by the name once again. I would say demo DevOps public IP. Press enter. Resource group name once again. Then we are going to add location. It will come from variable.location. Then we add allocation method. So it would be a static IP. Okay, I don't want to change it multiple times, so I'm going to write it as static IP. Followed by we need some network security group. Okay, we have to create that resource as well. So Azure RM network security group. Short form is NSG, network security group. Name would be demo DevOps NSG. Location would be variable.location. Then we are going to say resource group name once again. I'm going to paste that from here. Copy this data.azurerm.rg. I'm going to paste this. Then we need some security rules. So I'm going to open the braces here. Name is equal to allow SSH, followed by priority. We need to add priority. These are, let's say, all the manual stuff which we are doing from the portal. The same stuff we will do it from the Terraform code, infrastructure as code. If you try to create any virtual machine using Azure portal or AWS portal, I think the process is the same, but the way things look a bit different. But in general, overall, if we speak about any cloud, we have to follow the same structure, I would say, for virtual machines. Protocol. If you know about one cloud, then easily you should be able to create resources on multiple clouds. That should not be a problem. Source underscore port underscore range would be, I'm going to give it star, followed by destination port range. That would be 22. Then source address prefix. So all these things I am trying to follow the documentation and write. If you have any questions, please let me know in the comments. And also, you can go through the documentation as well. Terraform has, let's say, very great documentation. Prefix, that is equal to, once again I will say star. So our network security group is like ready. Now I would add network interface. So each and every virtual machine will have network interface. It's similar to our network card if you are using physical machines at home. So resource Azure RM network interface, NIC. Name would be demo hyphen DevOps hyphen NIC in double quotes. In double quotes, I'm going to write demo hyphen DevOps hyphen NIC, followed by the resource group name. Again, the same exact what we had previously. Data.Azure RM resource group.rg.name. Then comes the location. location is equal to variable dot location. IP configuration name is equal to, I'm going to say demo hyphen DevOps IP config, followed by subnet ID. That would come from the above Azure RM subnet ID, which we are creating in the same code, followed by private IP address allocation. That would be dynamic. Then public IP address ID, Azure RM public IP dot public IP dot ID. So this is also coming from the above resource which we are creating, public IP. Then comes the association. So we need to do some association between the network interface and with network security group. Yeah, manually also you do the same. If 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 you guys know what I'm talking, I think you might be aware. Manually also, when creating any resource using the Azure portal, we are going to do the association. So the exact same stuff we are doing here, but with Terraform code. Network interface security group association. My suggestion would be, before jumping into Terraform code and stuff, you have to create things manually and get to know the clear picture what exactly you are trying to do. Then jump into Terraform code. It will be much easier for you to connect the dots. Azure RM network interface, Azure RM network interface dot nic dot id. Then we are going to say network security group ID. So again the same nsg dot id. So all these are, let's say, coming from the above. Then comes the important part of this script, that is creating the virtual machine itself. Okay, before creating virtual machine we have to create all of these resources. Then we are going to create a virtual machine, Linux virtual machine. So the name would be VM here. I'm going to give a name, demo DevOps VM. Press enter. Resource group name, I will try to copy it from above. I don't want to type now. So I will copy this and paste it here. Then followed by location, that is equal to variable dot location. Then comes our size. I'm going to hard code this size here, standard underscore b1 s. You can write it using variables as well, but yeah, this is like the demo video, so I'm comfortable doing this. If you want, you can pass it from the variables file as well. That should not be a problem. So for example, variable.admin username, I'm going to pass it from the variable file. Then comes the network interface IDs. That would be Azure network interface dot nic dot id. Then OS disk caching is equal to read write. Then storage account type. Storage account type. Storage account type would be standard LRS. Disk is done. Now we have to do the source image reference. If you have watched my previous video, we created virtual machine locally on the virtual box. Same, we have to provide, we need to provide the source image reference wherein we are going to download it from the Ubuntu website and try to pass into our virtual machine. It is the same exact stuff. Here we are saying source image reference. Publisher is like canonical here. Offer, I am going to say, I will try to copy paste this so that I will not make any mistakes here. So offer is, let's say, 001 com Ubuntu server jammy. Then SKU would be 2204 LTS. I am going to copy paste that as well. Version would be latest. Okay, this is how we provide the image source version while creating virtual machine in Azure. Admin SSH key. So if you want to log into that virtual machine, you need credentials, right, to log into that machine. So we are trying to create that as well in advance. That will be part of our Terraform code itself. So username and then public key. So we are going to create a public key. I will show that in a moment. Public key is equal to file. I'm going to reference that. It will be .ssh slash Azure underscore Terraform underscore key dot public. Save this file. Okay. Then variables.terraform file. So in the variables.terraform file, we will try to write what all variables we added in the main.terraform file. So for example, we had only two variables. If you remember from this, location, always variable.location we are giving, and admin username. And that's it. I'm going to paste that here. Location is, let's say, Azure location, central US, and username is like Azure user I'm going to use. In the output file, we are going to write output as public IP, the public IP address of the Ubuntu virtual machine, so that it will be easy for us to connect. So to verify, I'm going to list the resource group location. So this is my location, central US, and this is my resource group. I'm going to copy this. And let's go back to our main.terraform. As I said, I'm going to paste this here. Okay. So now we have everything in place. Let's try to initialize, and no, I will need to go to this folder 05 VM Azure deployment. Yes. Now we are going to generate SSH key. So for that, I am going to run this command SSH keygen -t rsa -b 4096 and the file location. Press enter. It will generate public and private RSA key. I am going to give the password here. Press enter. Then once again, I'm going to give password. Press enter. Now we have a public key in place. Okay. So it is exactly pointing out to what we have defined in our main.terraform file. So if you see .ssh azure rm terraform underscore key dot pub. So if you look at here, the location, we are pointing it to the same location. Now let's clear the screen. Let's try to run Terraform initialize now. Terraform has been successfully initialized. That's great. Now the next step is like to run Terraform plan. Okay, so we can see some errors. So I see some errors now. So let's go back to each error and see what's going on. Error reference to undeclared input variable. On main.terraform, line 17, resource Azure RM virtual network VNet variable.location. Okay, let's check what's going on. So this is line 17 and I can see variable.location. Let's go back to the variables file. Here I have location. Everything looks fine, but why is it failing? Okay, looks like I did not save the file. Okay, I did now. Now let's try to run once again Terraform plan. So it looks good. No, I get an error. Yeah, still we have 3 errors. Invalid reference. A reference to a resource type must be followed by at least one attribute access specifying the resource name. Okay, line 35. Main.terraform. Let's go to line 35. So do I need to add in double quotes here? Try to save it. And let's try to run Terraform plan once again. Okay, did that fix the issue? No, I still expected allocation. Okay. I need to write it case sensitive. Save this file and then I'm going to clear the screen so that it will be easier to read Terraform plan. So I still get 2 errors. So main.terraform incorrect attribute value type security rule is equal to. Okay, set of objects required. I think I know what's going on here. I should not write security. It should be security rule. Now let's try to save this and let me clear the screen and try to run Terraform plan once again. So TCP, did you mean protocol? So you see, it is giving me hints clearly that I'm making some mistakes and I can, correct each of these mistakes. Followed by, let's look at the last error, Azure RM virtual machine. Invalid resource type. I can see Azure, did you mean Azure RM underscore Linux underscore virtual machine? Okay, there's a mistake. The typo. Okay, I'm going to update this. Always, better to copy paste instead of, typing. So I'm going to run Terraform plan once again. Hopefully now everything should work. No, I see new errors now. Missing required arguments 90. Line number 90. Caching. Save. And also there was another. Yeah, caching is required. But okay. This is done. Terraform plan. Okay, Terraform entered an error while generating this plan. Building unable to configure resource subscription ID could not be determined and was not specified. Okay, I know this problem. I need to provide subscription ID here. So let me quickly provide that. So we need a subscription ID. For that, I'm going to run this simple command to get the subscription ID. And I will try to add it here. Subscription ID is equal to the ID. Then let's try to run Terraform plan. So we should be able to, let's say, see the virtual machine now. So we see another error now. Terraform does not have necessary permission to register resource provider. Yes, I know this problem. We need to add this line here. If you don't have permissions to register resource providers, you may wish to disable this functionality by adding the following to the provider block. Okay, I will do that real quick. I know this. I wanted to show you guys what kind of problems we see. So that's why I'm keeping everything raw here. So clear the screen. That was, let's say, the last pain point. Now Terraform plan. So if you see, we are not creating a new resource group. It is trying to read my existing resource group. So this one, okay, followed by, also if you see here, plan 7 to add, 0 to change, 0 to destroy. I'm going to scroll up and look one by one. Virtual machine is getting created, followed by network interface is getting created, security groups association, security network security group is getting created, public IP, subnet, virtual network. Okay, now I'm going to say, let me clear the screen, Terraform apply, press enter. So it will ask me once again whether I want to, let's say, create this. I will say yes, create all these resources. Also, please remember, as soon as we create, we are going to destroy. Please do not keep it for a long time, otherwise you might waste your money there. Apply completed successfully, 7 resources added, 0 change, 0 destroyed. And also we can see the public IP wherein we can connect to that particular virtual machine. I am going to copy this IP and paste it here for temporary purpose, so that we are going to use it in a moment. I'm going to clear the screen. Let's try to check if our virtual machine is up and running. For that, I'm going to use this AZ command, press enter. So I should see the output of the virtual machine. It is currently running. Now let me quickly grab a command that we can use to connect to that virtual machine. Now let's try to connect to the virtual machine. I'm going to clear the screen. We are using AZ admin user here, followed by the IP address I'm going to provide. So copy this and paste it here. And also, if you remember, we created the SSH key, private key. It is stored in this particular location. I'm using the same key to connect to my virtual machine. Say yes. Warning, permanently added. Yes, we have successfully logged into our virtual machine. If you look, demo DevOps VM. I'm going to check the version of this virtual machine. If you see, it's the exact same version we tried to install. This is how we try to create virtual machine and also connect to the virtual machine using CLI. I'm going to exit from this virtual machine, and real quick, I would like to destroy the resources which I created, because I don't want to, let's say, come across any kind of cost. So I'm going to destroy using one simple command. So in total, we are using only 4 simple commands here: Terraform initialize, Terraform plan, Terraform apply, Terraform destroy, Terraform format, Terraform validate. These are, let's say, kind of checklist. And that's it. We have completed the full Terraform course. We started with Docker. We went on with variables, outputs, Drift demo, modules, and also deploying it to Azure cloud. The full GitHub repo, I am going to provide it to my newsletter subscribers. Make sure you subscribe so you don't miss my weekly DevOps labs and simulations. And if you want to go deeper, check out my 2 hours DevOps course on Git, Linux, Jenkins. Link in the description. If this video helped you, please do me a favor. Like this video. It really helps push it to more learners. Comment below, and most importantly, subscribe so you don't miss my weekly DevOps labs and disaster simulations.